From a live web page to a structured dataset, Minexa.ai compresses days of engineering work into a few clicks or an API call, perfect for scraping grant program listings. Browse to the page you want to extract. Minexa.ai works on any public URL, from simple directories to complex sites. Open the Minexa.ai Chrome extension. It works directly on the page you are viewing. Press the button, and Minexa.ai detects how the page loads more data, whether through pages, scrolling, or dynamic updates. All pages are in scope. Minexa.ai detected how results split across pages and will handle navigation automatically. Choose List Only for quick datasets, or detail pages when each row links to more information you need. Continue works for most pages. Use Advanced mode for interactive layouts, where data appears after user actions. Click Create Scraper if the block looks right. The analysis takes minutes and produces a scraper that works across all similar pages. Every data point is mapped precisely. Select columns like grant name, deadline, and eligibility to ensure consistent, accurate extraction. Click API Request to get ready to run Python code. All scraping logic from your training session is built in. Bad data stays out. Click Complete Configuration and Minexa.ai flags any page that doesn't match your setup. Multi-page handling is confirmed. All pages will be collected automatically on every run. Your job is one click away. Connect Google Sheets for automatic updates before confirming your scraping setup. Click Run, and Minexa.ai starts extracting immediately, applying deterministic rules across all pages with no reanalysis at runtime. Alongside visible fields like grant title, deadline, and description, hidden data such as attributes, image URLs, and nested structures are also extracted, preserving their original page relationships in the output. Export your records easily. If detail pages were enabled, each row includes the full content from linked pages. Try Minexa.ai today and replace fragile scraping scripts with a system that stays accurate and reusable over time.